installation of Docker, all the things we discussed yesterday. And today, what we'll start with the simple hands-on session with Docker on Cloud. 1 second, let me just check. I think the other participants, other key participants are missing here. They did not join. Okay, maybe office work. Okay, fine. We will continue now. So, how to install the Docker? Okay, the first step is how do we install the Docker? So, in the case of Linux operating system, especially AWS Linux, it is almost similar to your Red Hat Linux. Which one? The AWS Linux. Okay. Ubuntu Linux, it is little bit different. So we will be working on the AWS Linux. I have already created an instance on the AWS EC2 instance I created. Okay. So EC2 instance, something like a server, virtual server. I created it on the AWS Cloud. In that virtual server, we will see how to install the Docker and how to start the Docker and how to add the user to Docker group and why should we have to add the user to Docker group and what is the advantage of it, and also how do we automate this. Automate in the sense, right, all these steps we will put it in a shell script, and then when we share that shell script to other environment like staging area and UAT area and pre-production area. So all they need to just execute that script. It does all these things. We don't have to do it manually each and everything. Okay, that we will do it. We will take a look at it now. Okay, the first and foremost, right? What command we can use it to install the Docker on the AWS cloud. So 1 second. This is what my AWS cloud, and this is what my instance. I think my Kubernetes server got terminated because that is the one what failed to describe volume. Okay, there is an issue here. Let me see. Oh my God. Okay, now it's working fine. I could see some red color thing. So this is one issue you will face it, guys. Suddenly, they throw some, issues here. Some volume does not exist, fail to, because I was using the cluster, the Kubernetes cluster. Kubernetes cluster contains the master and slave nodes. So when you install the Kubernetes cluster, right? So what happens is by default it creates two slave nodes, worker nodes. So the worker nodes, what happened when even if I shut down, automatically it gets started. So there is something like auto scaling or something like that. Okay. So in that case, what automatically restarts even if I shut down. So what I did, I just terminated. I think because of which it's throwing the error. Let us ignore about that. So now I'm in the EC2 instance, the dollar prompt. This is where you can type your command. What did I do? I just selected the instance which I want to use it. Which instance in the sense I want to get into this EC2 instance. EC2 stands for Elastic Computing Cloud. I just selected this one, and if you click on the connect, it will take some time, and after a while, you can see the command prompt here. This is where you can type all your command. When it comes to like any cloud, you should be very good at Linux commands. Okay, how to work with the Linux operating system, especially, right? You don't have to be familiar with all the admin commands, but if you want to be a MLOps engineer or LLM ops engineer, you should be very good at the Linux commands, networking also you should be knowing it. Okay, some extent. Okay, so okay, currently I just go and type PWD. PWD stands for present working directory, which directory currently I am in. Okay, home EC2 user. This is good practice. Right, whenever possible, right? You just type PW. For example, you go to subdirectories and do something, and again you create another subdirectory. You go and work there, right? So what you do is, right, use PWD. That will help you to find out which folder currently you are in. Okay, this is not like a Windows. Okay, we don't have File Explorer and all. You need to be familiar with more Linux commands. Fine. So now I just type ls minus ltr. It shows all the files and the folders that are available in this root folder. What do you mean by root folder? So my user ID is EC2 user, EC2. This is the default user ID. that will get created as soon as you create a new instance, EC2 instance, okay, in the AWS cloud. Even if you create more than one EC2 instance, the default username for each EC2 instance was EC2 user. Okay, so the root folder, is home, /home /EC2 user. So here I just kept a couple of files here, right? So to run my applications and all the other dependent configuration files and package files, everything I installed it already here. Okay. So what we'll do is we'll see how do we install the Docker. Sorry. Okay. Here sudo yum install -y docker. If you give this command, it will install the Docker software. Okay, since I already installed it, I don't want to mess up it now. I just leave it as it is. Okay, sudo yum install -y docker. So what is this sudo? Sudo is your super user. Okay, but you are not a super user. EC2 user is not a super user. But to install any software, you need to have the super user. It's something like in Windows. If you wanted to install some software, you need to have admin login, right? Admin login, or you can in the command prompt you can log in as an admin. I can install it, something like that. Sudo is with super user privilege. You are going to install the Docker software. What is -y? -y is all the dependencies that are related to your Docker software will get installed if you give this command. Okay. So this is for AWS Linux operating system. This command is applicable. Okay, if you are using Ubuntu, sudo apt-get, sudo apt-get space install the software name you need to give. Okay, so here in this case, yum install -y docker. So almost all the flavors of Unix. See, in the Unix, different flavors are there. You have something like Amazon AWS Linux and Red Hat. Red Hat is the very popular one. It has been there since long time. And the CentOS, Ubuntu. These are the different flavors are there. And apart from there are some other flavors of Linux is there. And if you know, these are the popular one which I spoke, okay, which I told you. So in the AWS Linux, how do we install that? Using this command, you can install it. It's very clear, right? So now this one I already installed it. Now what I need to do is I need to enable the Docker to start on boot. Okay, as soon as I reboot the Linux operating system, it should get started, automatically, right? So what I do is for that I use sudo systemctl. There is something called systemctl. Sorry, systemctl enable Docker. Okay, now I did this, and then so what this command does, this ensures your Docker starts automatically whenever the instance reboots. That is good, right? Okay. Next, what I do is I'm going to start the Docker service. Sudo systemctl start Docker. See, this there is a typo. Okay, now instead of Docker, I mistakenly left the C. Now I typed it correctly. Now the Docker service got started. Okay, so this is the command. It starts the Docker service. Okay, this is the Docker service. It should be up and running. Okay, to allow the containers to run. Okay, I just type it all the things here so that you can recollect. Right. So for step one, you need to install the Docker. Okay, here sudo yum install -y docker. And step two, what we did, right? We just enabled the Docker to start on boot. And here what I do is sudo systemctl enable Docker. Step three, use sudo systemctl start Docker. So what is the difference between these two? Okay, what this command does, sudo systemctl start Docker. This is the one starts the Docker service. Okay, this is the one starts the Docker service. For example, you have not enabled the Docker previously, and then you restarted your server EC2 instance. In that case, right, you need to start the Docker service manually. Okay, so this is the command. This is just a command. Okay, for you to understand, this is the command you need to start. Use to start the Docker service. What is next? Next thing is this is another important step. The next one is you need to add user to Docker group. Okay, by default, Docker group will get created when you install it. So what you need to do is you need to use sudo user mod. So this is the command. This is a keyword, user mod. What I will do is I will just use G capital G Docker and then EC2 user. Okay. What this command does is this one will add this user to your Docker group. So why should I add the EC2 user, the default EC2 instance user called EC2 user? Why should I, add a user to this Docker group? The reason is you don't have to prefix sudo for each and every command. Okay. So for that reason, so basically, right, it allows us to run Docker commands without a sudo if you add the user to part of this group. See, this group is something like a company, right? Company. So employees are like the users, something like you just think, okay, something like that, okay. That's all. Okay, these are the four steps that we need to do it. So this one, what I will do is I will just show you how to do this one. The last command, sudo user mod minus G, and so okay, I just minus AG, I think so. Not user mod. Okay, this is what we have done. The first step is install the Docker software, and then you need to enable the Docker so that whenever you reboot the system, right, upon reboot, this service will get started automatically. And for example, right, you have not done this. In that case, manually you need to start the Docker service. Only when the Docker service runs, you can go ahead and create the Docker images. Once you build the Docker images, you can create the Docker containers. All right, that is what we have seen it so far. All right, so how to install the Docker, how to start the Docker, and how to add the user to Docker group, and how to automate this. Put all these commands in a file. Okay, for example, this is what I did it, right? I just save this as install docker.sh. Okay, I just what I'll do is here instead of doing this, I just copy all these commands and then I just come back here. I just open a notepad kind of thing here. Nano is a editor. Here what I do is I just create my own name. Okay, install docker dot underscore install underscore docker dot sh, and then I just copy paste all the commands that I used it a while ago. So this script file contains all the things. Okay. Here the step one is the ash. Sorry, here I know you put, and then here the step two, because the text and all you need to comment it. Right, ideally this is the one I should comment it. Okay, I should have used this command here. Okay, wait. And then right, so same way you just go here and comment it, and then sudo. Best thing, right? You can just type it in your Notepad plus plus also, all the commands, and then press Control O to save this changes whatever you made in this file on Linux. Okay, just Control I press it and press Enter, and then press Control X to come out of this. Now, if you type the command cat install docker.sh, this file is available now. Right, so all they need to do is if you share the script to other environments. See, in the real time scenario, what will happen is this is you just think this is your development server. This is where you do all kind of development. Once you did all your development task, right? So your code and everything will be pushed to other environment. Similar to this server, there are different other servers are there. So each and every server, you need to install the Docker, right? So in that case, right, you don't have to install it, everything manually. You can put it in a script. You share the script or push the script to other server, and all you need to just type dot forward slash install docker.sh. This script will get executed. Okay. No such file. Okay, let me do one thing. ls-ltr install docker.sh. Install underscore docker.sh. Permission denied. Okay, you need to change to chmod plus 777 ISDF. This is read write privileges. Read write execute privilege docker.sh. And then if I give this command install, now it's working fine. Fat, right? Dependent package already installed, very good. So the dependency is resolved, nothing to do, complete. Okay, user mod group does not exit. Okay, leave it. Okay. So all these steps we have automated it using a script, right? We don't have to execute each and every command. Once you create a script file, install underscore docker.sh, all you need to just execute the script. That's all. Okay, so that is what we have seen it here. All these steps we have carried out so far. Next one comes the real action, right? Now only we are going to get into the real action part. So the next step is we need to create a Docker file. So before we create the Docker image, we need to have a Docker file in place. So why Docker file is required? Because when you build the Docker image, the Docker, right, it reads the Docker file and it builds a new image using the specified instructions in your Docker file based on the instructions that you gave it, right? So it will build the Docker image, okay? And then what will happen is the image which got built, right, that will get stored locally. That gets stored locally in your operating system. So what you do is you can push that the Docker image which got built, right, and it is available locally. You can push it to your repository, easier repository. Okay. The first and foremost step is before you building a Docker image, you need to create a Docker file. Fine. Okay. So what is a Docker file is all about? It's kind of a configuration file. So okay, once you create a Docker file, right, and then the next step is you build the Docker image. Once you build the Docker image, the next step is you can run the Docker container, right? You can run the Docker container. This is at the high level, okay? These are the three steps that we need to follow if you want to create any container, okay? So the base is right. First, you need to have, this is a prerequisite. First, you need to have a Docker file. This is a kind of, right, configuration file. So using this, in this file, we mentioned all the dependencies and what are the instructions it has to follow while building the image during the image building process, Docker image building process. And then once the image gets built, you need to run the container. The run the container, the last step is, that is the one creates the actual containers. Okay. Fine. Now what we will do is we'll go ahead and see what is a Docker file, how the Docker file content looks like. This is this is a sample Docker file. I just put it here. The same thing I used it in the Linux environment. Here, look here, ls-ltr. I just type Docker file. I just look at here. Yes, this file is there. If I want to view the content of this file, I can use a nano. It is kind of a notepad, okay, editor. So Dockerfile, I just open it. Yes. So oddly, we could see six lines are there, right? 6 lines of the instructions are there here. So here you can see that public, the first one from public ECR AWS Docker library Python 3.12 Slim. Okay. What does this tells? The first line. This line sets the base image for your Docker image. Which one? The first line. Basically, it puts the lightweight Python 3.12 Slim image from a verified public AWS ECR repository, guys. From the ECR repository. You can also pull this from the Python, Slim Python. There is something called Python library, right? That is available. Usually, when you see the Docker file from the internet, right? So it will be something else, not the ECR one. The reason why we used the easier, right? Many time you may have to pull the image from the repository. So in that case, you will run into issues like number of the number of pulls got exceeded or something like that. Okay, to overcome that, I have used the easier repositories image. Okay, this image it pulls basically it pulls the lightweight Python 3.1 to Slim image from ECR repository. What is Slim? As I told you previously in the last session, right? Using Slim image means it will have the only fewer the necessary files, right? It keeps your image size smaller. Okay, not all the Python related dependencies it will install. Okay, just the basic version of your Python will get installed, so that it will make your image size will be small. Okay. Next one is the setting the working directory. What is setting the working directory? Here I set the working directory as APP. Okay. So what happens here is, this is the one, create the working directory within your container as APP. Okay. And then what happens? Copy all the files, dot in the sense the current folder, copy all the files that are available in my operating system to the app folder inside my container. Inside you just think, inside the box, we are pushing all the files under the app folder. And then what we are doing is all the dependent files on the right, or the packages that are required to run your application, we are installing it using this command inside your container. Okay, and then finally, we are exposing with the port number 5000. What is this 5000 is all about here? Expose 5000. This is the port number we already discussed in the last session. I discussed. So this one tells the Docker the container will listen on our port 5000 at runtime. Okay, during the runtime, the container will listen at the port number 5000. Okay. So this is right in the context of Flask application, port 5000, right? The port. See, we discussed about the Flask application also. It's a web framework. Right in the context of the Flask application, the port number 5000 is typically used for serving your application. Okay, so it will serve your application to the Flask server, so that the end users can send their data to your model in the form of user interface. Okay, and then the model will throw them back with the predicted values. Okay, so basically this port number 5000 is for a Flask. Okay, so you see this pip install, what it does is, while installing all the necessary package, it install the Flask application also. Okay, so now what we are doing is expose that Flask thing, right, to 5000, port number 5000. Right, when it comes to the Flask application, the port Pi 1000 is typically used for serving your web application. Okay. So here the expose, remember that, okay? It does not publish the port, guys. It just documents it. That's all, okay? You still need to map this port when running the container. Okay, I'll just show you that one. Don't worry, okay? You still need to map this port with the Flask application, okay? See, you have something like your Docker run. When I show you that one, I will explain this again. Don't worry, okay? The last command is CMD. What is CMD? So basically, this is the one sets the default command that needs to be executed when the container starts. What happens is it runs your Flask application by executing app.py. This is the file, right? app.py. I showed you in the last session. This contains this file contains the Flask application. I imported the Flask application and then I created the endpoint. Okay, everything I did it in this app.py, right? So in this case, what happens is it runs your Flask application by executing app.py using Python programming language. Okay, fine. So these are the I explained you step by step, right? What each instruction does. Now I'll show you what this requirements.txt is all about. Requirements.txt. All these packages will get installed inside the container. Container in the sense the box. Okay, everything we are installing it inside the box. The simple example is ceiling fan. Let's say you want to buy a ceiling fan for your house. Let's assume that before they ship the ceiling fan to you, they assembled everything. They take the screws and nuts, and then they take out the four blades of your ceiling fan, and then they take the fan motor, and then they assemble it everything together, and then if they ship it, you don't have to break your head, right? So rather than shipping the assembled ceiling fan, if they ship all the spare parts, the blades separately and then nuts and screws separately, and then to hang your fan, they need some kind of pipe, and then the motor, everything they need to ship it. If something is missing, you cannot install it. But they say in my place it is working fine, the fan, but in your place it's not working. What can you do? So, right? So to overcome that, we use Docker. Something like you assemble everything to run your fan, right? Same thing here. So you Dockerize or containerize all the dependencies, including your application, and then if you push this Docker container to any environment, it will run. It doesn't for example, in this EC2 instance, I have used the version Python version 3.12. Maybe in the other EC2 instance, the version of Python is different, right? So when you create a container, everything will run inside your container. If you ship it to other environment, it will still run irrespective of the version issues and all, right? So for that purpose, see the requirements.txt, we need to list down all the dependent packages and application that needs to be installed. Okay. So scikit-learn is your machine learning related package, and pandas for data analytics. NumPy is also to perform any numerical thing, and joblib is to create a pickle file. Okay. And Flask is your web framework. Okay. So once you create your model, and right, once you create your model, next step is you need to expose your model to the outside world so that people across the globe, they can use your model, especially within your organization. Okay, all the stakeholders in your company who lives across the globe, they can use your model, right? The model which you serve it on the cloud, right? So the same thing is applicable here. That is what I'm trying to say. That is what is happening actually here. Okay. So first prerequisite is you need to have the Docker file. You mention all the dependent files, what are the dependent files or packages that needs to be installed. And then the next thing is you need to specify the working directory. First thing is, yeah, working directory you need to specify it, and then you copy all the files from your current directory. See, if I say PW, right, all the files, whatever the files that are there here, for example, here, right, This one will get copied to app directory. Hence, you need to make sure that you are keeping only the relevant folder, relevant files in this folder. Otherwise, what will happen? All these junk files will also get copied there. Okay. So that is what we saw. So now my Docker file is ready. Okay, and I explained you what is requirements.txt. This is the whatever the files that you or whatever the package names that you mentioned inside the requirements.txt that will get right executed inside your container. For that, we have given the instruction pip install requirements.txt. That means right each and every package will get picked up one after the other and will get installed everything inside your Docker container. Okay, so now we define the Docker file. I explained you the Docker file, okay, that contains the set of instructions that needs to be followed while building the image, okay, while building the Docker image. So the next step is we need to build the Docker image. First step is over. The second step is we need to build the Docker image. How do I build the Docker image? We have something called Docker build -t. For example, I just give Flask app, Flask-app. And importantly, at the end, you need to give dot here. One second, I'll just increase the size of it so that all of you can see it. Can you see it? Yeah. Docker space build -t Flask app. This is my image name. Okay. Build a Docker image with this name and make sure that for this to build the Docker image, the Docker file is available in this current directory. Dot is the current directory. The current directory Docker file is there. You go and pick up that, and what are the instructions we gave it in that Docker file, based on which you build the Docker image with this name. That's all, guys. What is this -t? That is the option. Okay, that is the flag or option that assigns a name as as Flask app to your newly built image. So okay, if I don't give -t, what will happen? Good question. The Docker assigns a random name and ID to your image. That is not the best practice. Always use -t to assign a name to your Docker image. So now I just press enter. Let's see what happens. Now it is building the image. Error. See, fail to copy, fail to open target, open war lib on device. Find us. Okay, no space is left on device. No space left on device. Already I have created so many images because of which, I don't have space here. Either I need to increase the space. Okay. Rather, what we can do is we have something else. What I'll do is I just remove all the previously created images. Okay. For that, we have something called a prune command is available. Okay. Using which we can remove all the things. For example, what I do is docker prune, docker system -c I'll give here. And when I press enter, sorry, -c, right? I put one here. Yes. It asks for my confirmation. Are you sure you want to continue? It will right. This will remove all stopped containers, all networks not used by at least one container, all images without at least one container associated with them, all build cache. I just press enter Y here and then I press enter. It will remove all the dangling images, right? That was not used, right? So now it reclaimed the space 4.245 GB. Excellent. We got sufficient amount of space to build the Docker. I just press the up arrow to reuse the previous command. I don't have to type it again. Now, okay, sorry, not the pro, sorry. I want to build Docker build -t Flask app. Now only it is, now it's rebuilding the image because we have cleaned up space. Now it is copying all the files from my current directory in my EC2 instance, to the app folder that is available in my container. So it is a best practice. Make sure that only required files you keep it in your folder. You can probably create some other folder and keep all the relevant files for your Docker to use it, right? And then you start build the Docker. Otherwise, what will happen is all the files, unnecessary files, will get copied there. Now it is installing all the dependent the packages or dependent applications, all the other dependent applications that are required to run my application successfully, right? It's installing everything inside the container. And I could see something red thing here. Let's go and see run pip install requirement error. There is some issue here. Okay, we will see copy.app work directory app downloading. Everything is happening here. And then, yeah, Dockerfile process failed to solve bin did not complete successfully. Sometimes you will end up some issues like this. Okay, let me just see what that issue is all about. Mm, okay, this is the one called failed to solve. Expose port 5000 for Flask. Failed to solve process bin sh minus ep install no cache did not complete successfully exit code one. There is some other error. Okay, usually it will run successfully. Okay, I'm getting something error here. Did not complete successfully, right? So maybe the package version problem or something like that. Okay, please. So the reason could be various, maybe package name was wrong or let me just check here. Cat requirements.txt. Everything is correct only here. Maybe right network issues. Maybe right some packages are not getting downloaded. Mhm. So what I will do is I'll just troubleshoot that by using the pip install command here. Okay. So you inside the Docker file, we have this command, right? See Docker file. So you will end up some issues like this. Not all the time. You will have a cool time, right? Sometimes what will happen is, you will develop some issues. It will throw some error. You should be able to fix it. Okay. You need to troubleshoot it and fix it. And here what I'll do is I'll just install it from the command line itself. Okay. Let's see what is happening here. I just remove this one and then see if this is going to. So what is pip install? Pip is Python's utility. So using which we are going to install each and every package that is listed in the requirements.txt. What is minus r? Minus r will recursively. That means it goes to this file and takes each and every package and install it. Okay. I just press enter. Yeah, requirement already satisfied. Okay, then why I was getting that error? Everything is working fine. Package. Okay, what I will do is I will just prune it again. We will rebuild it again. Prune minus A. Yeah, I will just prune it again and then we will try it out again. Due to some space issue also it can cause some problem or version issues or network issues if it could not download everything. The only way out is we need to install it manually from the command line. So now we were able to save 2.41 GB space again. And here we will try again the same thing because this one was working fine. And let me do one thing. I'll just check are there any problem with the port number. So what I'll do is ps minus ef grep docker. Okay, here you can see that yeah, 5000 was already used by something else, right? Mm, this could be also be another problem. Okay. Mm, so now we need to check. So now we could see that these are the things are using my port number 5000. Probably you can change it to 5001 instead of using 5000. Okay. What I'll do is I'll just go here and then I make changes to my Docker file. So before you rebuild that, make sure that what issue that you can suspect it, right? What I suspected, the 5000 port was already used by some other thing, some other images or containers. I just changed to 5001 and then I save it. Now what I'll do is I'll just go ahead and create it. But I could see that there are some issue with pip install previously, but still we will see. And the meanwhile, I just go and check here. I just now open another EC2 instance. Same instance, but I'm going to open another command prompt for the same EC2 instance. I'll just open it. I'll just connect it so that you can work side by side instead of waiting this, right? Waiting for this to complete. You can work side by side on the same. So it's building now. And now let us go parallelly and go and check what are the images are already available. Okay. You can use Docker space images. This command will give an idea of what are the Docker image that are already running. Okay. So this is the Docker image that is already running there. Okay. Iris Flask KPP. This is the one is already running. This is the one, right? This command helps us to list the Docker images that we created already. Okay. And also I'll just use Docker system df minus df. All right. So yeah. So this is the one help me to understand the disk usage by the Docker. How much disk used by my Docker? Okay, here you can see that the image is 1.6 GB. In container, it takes 1.403 MB only, and the build cache was 2.411 GB. Okay, this is what we could see it here. So with this command, we can find out how much space is utilized by image and container of the previously created one. Okay. So what we can do is, right, so that's what I removed the images that were not at all in use. And if I want to remove a specific image, that is also possible. Okay. What I will do is Docker PS. So Docker PS will give the containers. Okay. DOCKER PS. Okay, this is what your container ID. Look here. So this is the one is already using it 7 hours ago. So what I will do is I can probably remove this and the container, right? Right. So sorry, I need to probably I can delete this container also. Okay. How to delete a container or remove a container? So we can use the RM command. Okay, Docker RM command you can use it. For example, I just use Docker RM and then the container ID. If I give this one, it'll remove it. Maybe because the previously used one cannot remove container. Container is running. Stop the container. You need to stop the container first, and then only you need to do this one. Okay. Okay. Before we start that, let's go and check what is happening here. The same issue is coming up. We are not lucky. Okay. Expose port 5000 for Flask. Used when run. Oh, in the app.py I'm using. Okay, this is what the mistake I did. App.py. And here the port number, I think somewhere I used the port number. Yeah, here, look here, 5001. There is a mismatch here. This is the app.py. So here I mentioned one 5001, there I mentioned something else. This is the issue, I think, okay, because of which it is throwing an error. I will rebuild the Docker image again. Same issue we are getting. Fail to copy files. Fail to open target bar lib. Okay, where is some other issue? Chunks.py open to space left on. Okay, again space issue came up. 1 second. There you go. So what I will do is I will better stop the container and then I drop the container so that we can create some space. Here, Docker. Don't worry, I will explain all these steps. Okay. So this is a container that is already running. If I try to remove this Docker container which is already running it, it throws an error because it's already running. I need to stop it, right? Docker stop this container. This container you need to copy it here so that this one will get stopped it fast. And then Docker RM. RM is remove. Let's wait for a few minutes. Because so many containers we created it, so many things we did it, okay, because of which it was running out of space. Either you can increase the space, but no need, okay, Docker RM, and I removed it. Again, we will go and check whether that container got removed. Yes, it got removed. Now what I'll do is I'll just go ahead and clear up all the space used. Prune, Docker prune. Okay, Docker system prune -a. Yes. And then Docker images. This list out no images are there. Good. So now it is clean. I just go ahead and rebuild the Docker image again. So now you must have understood, right? You need to have hands-on here. It's not like watching the videos and don't expect watching the videos you can clear the interview. Different times when you run it. See, I've been giving the demo for other two different set of people yesterday and afternoon and today evening and all. It was working fine. Suddenly, right, some other issue may come up. Hence, hands-on is very much important. When you install it in different environment or in the same environment, when you install it more than one time, you will encounter more issues. The more issues when it comes, you should know how to troubleshoot and fix it. No one will come and troubleshoot and fix it on your behalf. And again, you could see that, right? It takes a lot of time. It takes quite a time, right, to build the image. And the next step is the install step. Pip install everything, right? If there is a still problem, right, I need to allocate space on the things. I need to raise a request with AWS because I'm using Kubernetes related thing also here. They take usually, right, 24 to 48 hours to approve the request to increase the quota or something like that. Any request you raise it, they take their own time, right? So for 48 hours or 24 hours, rarely I could see they resolve the issues, within 12 hours or 14 hours. Anyhow, I changed the port number and again I stopped the container, right? So I shouldn't have changed that port number. Before changing the port number in both the Dockerfile and app.py, we could have stopped that container and deleted the container and then we could have tried because that container, the one we saw, right, that was running right already, that was the one using the port number 5000. If the port number was already used by some other application, and if you use the same port number, if you try to build some other image, right, it'll throw it. So this is where the cache, the install was the problem. It is downloading everything, somewhere it is throwing an error. And the war folder, yeah, so the system folder, right, it was not having problem. So it was not having sufficient space, it seems. Anyhow, I have cleaned up everything. Now it is exporting the layers. So what are layers? Very good questions, right? They are immediate step in building your image, okay? So it is nothing but each command in your Docker file creates a new layer, okay, which is cached and reused to speed up your builds. Successful, very good guys. We are able to create the Docker image successfully, even after posing a lot of challenges. Okay. Now we will check, whether what So now we need to double check whether this image got created or not. So already we could see that no error, nothing. So still, right, we have a command, Docker command. So Docker images. Using this, we can see that image that got created now. You can see that Flask app, that image got created. And the default tag is latest. And image ID is this one. and then created 3 minutes ago, and size is 1.69 GB. Now we could see that, right? So that is what we can see it now. So now that you understood how to create a Docker image, and we post issues. What are the issues that we posted? This is very important, guys. You need to document it. Okay. So what are the issues that we posted? We post some space related issue, right? In the var folder, some issue was there. So what we did, we just used the prune command to remove all the unused images. Okay, and then we were able to claim 4 GB space. And then again, when I tried to build the image, I was getting some issue related to the port number, because the port number 5000 that I mentioned it that I mentioned it in my Docker file as well as in my app.py was already used by some other container. I had to stop that container before I delete that container. Okay. But in real world scenario, don't ever delete the container blindly. You need to make sure that, if that container is really required. If that container is really required, you don't disturb it. Rather, you can, use a different port number. For example, in our case, the container which we removed it, that was using the port number 5000. What we could have done was, right, we could have changed the port number 5001 in our Docker file as well as in app.py, so that the new Docker container which gets created, that one will use the 5001 port number. Okay. So build the Docker image, list images. So now we have built the Docker image using Docker build -t and the Flask, the Flask app as the image name, and followed by that the dot. That is very important. Okay. And then next step is with list images using Docker space images. We could see that the image which got created, right? For that name we could see that, and also the image ID we could see that, and how much space it used, that we can see that, and then what time it got created we can see that here. Okay, and then what is the disk space used by Docker in this case? So Docker system df we can use it. Okay, one second. This gives you the detailed information. Here you can see that image is only one image. The size is 1.6 GB. Reclaimable 1.68 GB. Okay. Container 000. Local volume 0. And build cache 10. And then the cache, it consumed almost 1.2 GB space. Okay. And then if you want to you want to check the detailed resource usage. What do you mean by resources? The space, how much space utilized used on your hard disk, and the cache, how much memory got used, right? Memory, hard disk, CPU, these are called resources. Okay. If you want to get the detailed resource usage followed by the same command, right? You need to specify v -v. This one will give you the detailed information about everything here. The images, space usage, and repository tag, everything, right? The cache ID, cache type, and size, and created last used, usage, shared, true. You could see a detailed information about this. Again, it requires, more knowledge about this one, okay, to understand each and everything. What is cache ID, all the things. Again, you don't have to get into too much of detail about this. Okay, this just give you an idea. Okay, with what all resources consumed, how much or disk space, and how much memory, all this. You can see 43b, right? Source dot local something, but any of this is not going to be much helpful. Now that you understood how to build an image, how to troubleshoot in case of any issues, how to troubleshoot it, and then how to view the Docker image which you created, right? So now I created it. Now that command got disappeared. If you want to see it, right, what images are running, what images are available currently, Docker images, if you type it, you can see this. Sorry, Docker space images, not images. So it gives you Flask app about this information. If I type clear, everything gone. Again, if you want to see what images that you created, for example, like you in your team, right, MLOps team, multiple people, they may be creating the images. And if you want to see how many images are there, how much space utilized by each image, if you want to see it, you can see it there. And also, if you want to, if you think any one of the images not required, no longer required, so in that case, you can remove it. Okay, and then Docker stats. There is something called Docker stats using which you can check the system, the monitor your CPU and memory usage. Something like in the Windows, when you put control or the task manager, right? Something like that. Okay. Here currently it's not showing anything. And then if you want to remove a specific image, you can use Docker space RMI. Before that, you type and check. Okay, these are what are the images are currently created available. Flask app, that is the image we created it. And then yeah, this one. If you want to remove it, you can use Docker RMI and then the container ID. Sorry, the image ID, not the container ID, image ID. Okay, this is the image. If I click on it and if I copy paste, it will get removed. Okay, so I don't want to remove it again. Okay, if you want to remove it, you can remove it. RMI. What is I? Remove. RM stands for remove. I is image. RMI. Remove image. I. Okay, Docker space RMI space image ID. And if you want to remove all unused images, you can use Docker image prune. Docker image prune minus A. A stands for all, right? Prune in the sense, remove all the images that were unused. So in this case, we created the image, but we have not yet used, right? So how do I use this one? Now what I'll do is I just go here. So we explored all these topics related commands, right? Remove unused image, remove specific image, all the things we explored. Remove all unused images. Prune command we can use it. Docker space Docker system prune space minus if you give, it will remove all the unused images. Now that you learned how to build an image, that is a blueprint. With that blueprint, how can I build a house? Okay. How can I create a container? Building an image is not sufficient. Now we need to create a container. How do I create a container? That is where we need to use the Docker run command. Docker run minus P. Okay. You have something called Docker run minus D minus P. What I will do is now I just go to the command line here. I just type Docker run minus D minus P. And here in our case 5001 and I'm going to say 5000. Okay. Okay, this is my, I just say 5001 here. Okay, in this case, yeah, I just put the next thing is Flask app. This is the image name, right? Flask hyphen app. This is the image I built it a while ago. I want to create a container based on this image. Okay. So in this case, I mentioned Docker run. What does this Docker run command does? It starts a new container from this image. What is minus P 5001 and 5001? What is this one? So in this case, it forwards the port 5001 of the container to port 5000 of your EC2 instance. Here, let's in my EC2 instance, I don't have any other process using the port number 5000. So you understood the left side of the port number 5001. That is the one your containers. That is the one is your container port. Okay. See this is your this port 5000 of the container array, right? That we are mapping this port 5001 container port to the EC2 port number 5000. Okay, I just press enter. Let's see what happens. Now a Docker container got created. Now a Docker container got created. Now how do I check the container got created? So using Docker images, we could see that the images, as soon as you create an image, you can use this command to check right? Whether the image got really created or not. Using this command, you can say first step. But how do I check the Docker container whether it's really created or not? Here we get some number, right? You can use Docker PS, and if you see like that, if you press enter, you can see that the container ID is this one, the Flask KPP, the image, right? For this image, it creates the container ID, and then it is listens at the port number 5001, and it this 5001 of your container ID port got forwarded to your EC2 instance, which is my Linux local Linux port number 5000. Okay, fine, it's working fine. So now what we have to do is we will go ahead and check the the public IP address for this instance. So I just selected this. Just beneath this, you can see something like networking. Just click on it. And then I just select this public IP address. And then I go to the browser and then I type it here. And then I just type 5000. That is the port number of your EC2 instance. But will this work here? It will not work, right? It's not working. Just wait for some time. Still, it is doing something. And I'm using 5001 here. Now the app.py, what that command does is that command now the container is running, right? It is already loaded the model.pkl file in my Flask application. Now we are deploying that Flask application here, but here unfortunately it is not showing it because there are some other issues. We need to go and create the security rules here. So you have something called security rules here. You don't worry about this one, okay? These steps we will see it later, okay? One second, I just go back here because the 5000 port I'm using it first time now. Wait. Okay, here in the security, you need to click on the security. So you need to go and define 5001. You allow it to the access the port number. Okay, for that you need to edit inbound rules. Here you need to add a rule here, custom TCP. I just say 5001 here, and then I just scroll down here. Anyhow, don't worry, guys. We will do it one more time so that I can walk you through everything step by step. In the meanwhile, you can watch my video and also you can give it a try. So now I have opened that port, right? So that anyone in the public can access this port number, in this EC2 instance. But still, it is not running. Okay, there is something wrong here. Yesterday, I showed you, right, how to serve that model on cloud. It was working fine. Now it is causing some problem. I just go here and then the security group will check one more time, edit inbound roles and all the custom TCP and everything, right? Okay, fine. And here I mentioned the port number. Okay, where is the 5001? It is there already, but still it is causing problem. Okay, let me do one thing. I'll just go and type that command here, Python 3.1.2. And then, so I'm going to execute that Python app.py file manually here. And then we will see, what port number it is running it here. We could say, yeah, already in use, 5000 is in use by another program. Okay. Either identify and stop that program to start the server with different port. Okay, because in the app.py I use that one, right? So because of which it is throwing this error. And now what I will do is I just go back here, Docker PS. This is the container. Okay, one second. I'll just clear all the mess. Now 5001 is mapped with my 5000. Okay. And now we will see, we will do one thing. We will see. Now what we have to do is we need to check which process using the port number 5000. Okay, in AWS Linux. So that is what we need to do it. For that, we have a command. Okay, ls lsof sudo lsof. And still, it is using some other thing here. -l colon 5001. Okay, sorry. So this is not, sorry, instead of typing I just typed it this one. So this is the command that we can use it to check, which process are using the port number 5001. We can see that root is already using this one. Okay, maybe some other issue here. Okay. Mm, TCP commits, yeah, so there are some other things are using the port number 5001. Okay, so that's the reason why you need to be cautious before using the port number. So now what we have to do is we need to go to the Docker file, and then you need to give the different port number. Okay, and then you need to rebuild it. Okay, quickly we'll do it, and then we will see what is happening. Okay, because the port number 5000 was used by some other system related process. I could have used some other number. Okay, the four instead of 5001. Now anyhow, the 5000 is not at all used. And then nano, we never expected the 5000 was used, that port number was used by some other process. I just go ahead and make a change here and 5000. And then I just, sorry, I'll do nothing. Okay, 5000, right? Okay, okay. And here, save post, okay, control Y. We'll double check it, and then I just go down here, and then the port number I change to 5000. Now what I will do is I just use Docker PS, and then I'm going to stop this one to overcome to address any, further issues, right? So Docker stop the container ID. Sorry, not this one. I'll just copy and paste it here. So this is how you pose issues, last minute confusions, everything. I just go here and then we will prune everything. Otherwise, if I rebuild that Docker again, right, it will cause some issues. Okay, Docker system prune -a. Yes. So first we will clean up the space. Otherwise, we can increase the hard disk space. But again, that involves additional cost, all the things. Again, it takes time. Better we will rebuild that Docker image once again. Okay, Docker build. Okay, I'll type it. Docker build -t and Flask -app. I just give the same name, or we'll do one thing. I just give it something like Iris Flask app. Okay, here, okay, okay, Docker build. See, I forgot that command. -t. Okay. See what mistake I made it. Can someone tell me? I was emphasizing that specific thing, right? I did not specify dot here. So you need to tell the Docker to use the Docker file that is available in the current folder or whichever folder that is available. You need to specify it very clearly. I did not put dot here. That's the reason why it is throwing that error. Okay. Now it is rebuilding the Docker image with the port number 5000. Oh, now only it goes to work directory. Yeah. It has to install all the packages. I need to do it once again for you guys, this demo end to end. How I created the .mdl file, all the things. What files that needs to be there in your current folder, everything, right? I will have to give a demo again. This is just a, trial run. Okay, you just think that way. It takes quite a time, man. So Docker image to build that. So that's where you have to have patience. Good. Now it got built. The image got built successfully. Now we will run the Docker. We will create the container. Okay. Docker run -d -p 5000 port number I'm going to use. And then the image iris flask IP, right? The image name was iris hyphen flask hyphen app. Now it's running perfectly. And if I go here and then if I click on it, it should serve the model here. Now we could see that the model got served successfully, right? Yes. So now you can see that here, for example, sepal length is 6 and 4, 3, 1 or something like that, right? If I give that and if I click on the predict, see, this is how the end users, they will use your model to give the input values. And then if they click on the predict button, your model has to throw back them the predicted values. One second. I think the values are not correct. Okay, 4. Okay, I just use something like 2. Yeah. So this is the one. Okay, I should have told them. Versicolor. A flower with this combination of 4 measures called your versicolor. See, iris flower itself contains 3 different categories. One is the versicolor and virginica and setosa. For each type of iris flower has different measurements. Okay. So with these 4 combination of measurements, we can see versicolor. Okay. Something like that. Okay. So that's what we can see. Now the model got solved perfectly. Now the question is, if I don't use minus p 5,000, what will happen? What will happen? It will not serve the model here. Why? Because we need to forward this Flask container port 5000 to your operating system, in this case, a Linux operating system port number, so that when you try to access this port number, what will happen is this one already got forwarded with your Flask, app thing, right? That one already got forwarded this one. Hence, what happens is it serves your model. If you don't specify minus p 5,000, it will not serve the model there. Okay. Okay, and now the question is, right? Someone asked this. Okay, that's all right. You don't have any other questions. Okay, fine. What was that? Yeah, you can use a different port number also. Unfortunately, the port number 5000 was used by some other process, right? Python or something like that. That is what we have seen. Hence, you need to be doubly cautious before you specify the port number. You check, if that port number, whatever you are going to use it, whether it is already used by something else, right? For that, you can use a command called sudo lsof space -i, and then followed where you need to specify the colon. Look at lsof hyphen I, not L hyphen I 5001. If I give this one, it will, sorry, not the L, I mistakenly typed the L here, I. So this is the one will tell you what port number. Yeah, 5001 was not used previously. There was some confusion happened. Now we could see that the 5000 port was, running, right? So that was listening the request from others. That time maybe, right, some other thing was using it. Now, we are all set. But make sure that in the Docker file and app.py, also you are going to specify the same port number, okay? Don't specify different port number. That is also another thing. Next thing is in the tomorrow session, we will do more hands-on. We will have some kind of assignments, okay? We will work on those kind of assignments so that you will become more familiar with all the Docker commands. Try to practice everything before you get into a job, okay? Before you take up the interview, so that, luckily, if you clear the interview,